All right, welcome folks to Last Week I Learned. This week is quite a departure from our previous themes, and I'm really excited about it. It's a chance for me to kind of geek out. I work in ad tech, which is kind of like the backbone of the internet you never see, and you sometimes interface with in the form of, pop-up ads, which we can all agree are not good. But this week's theme is web performance, and ads have a critical role in web performance. Like some blame ads for the slow web, right? And there's some truth to that. But what I really wanted to think about was how to improve web performance. How do things move faster on the internet, right? And so we're kind of in this weird place with the web where we have this incredible technology, we have these amazing devices, and we're almost like pushing them too hard, which is really interesting, especially with AI. We're going to see this more and more. I mean, even Apple has moved a lot of their computing from the device to this like private AI cloud they've built out, right? And they don't want to do that. Let's be clear. They would love for everything to be on device for privacy reasons and just for ease of use. But they've made that decision and they make some of the best hardware in the world, right? So whether it's ads or AI, we are asking more of our devices than ever. And so I'm curious about how we can make this better, right? How can we make things faster from a technology side, whether it be a better web browser or writing better code that can help things move faster on the web. And so I'm going to start with, how we got to now. I'm going to talk with what we can do now. And then I'm going to talk through where we're going, right? And so as always, you can look for my sources in the show notes. And I think I've got some really good ones here. It's kind of overwhelming, so I recommend looking at, I've got an article published with kind of a condensed version, but of course you can see my full sources as well. That'll be linked in the show notes. So let's start with how we got here. So first of all, let's start with the web. How did we get the web? So the web came out of some research funding for basically nuclear fallout, right? The idea was, let's say cell networks go down and telephone lines go down. I guess there were no cell networks at this time. Let's say telephone lines go down. How do we communicate? And this was, at the time, I think it was ARPA, Advanced Research Projects something, which is now DARPA. And they were doing some basic research on this in partnership with a bunch of other countries, and they developed the World Wide Web, right? So at first, the World Wide Web was just a bunch of servers, and you had to be connected to one of the servers or one of the computers to get access to the information. Then when you did get the access to the information, it was just basically, I think it was just TXT files, right? So you could just see text. It was text only. And of course, we've come a long way from there, and the next kind of big development I'm going to jump to is what everyone called Web 2.0 at the time, right? So this was around the time of the dot-com crash in the early 2000s, late 90s. So this was when you had Netscape and Microsoft battling it out. And this was when Microsoft actually, I think they won the antitrust lawsuit against the government, but they were forced to allow other browsers, other web browsers on their operating system, right? So the web browser was the king of Web 2.0. It took these text-based files, which were really hard to get to for anyone other than an expert, and democratized them, right? So all of a sudden, anyone could really easily look up a web page and find a recipe, or, I don't know, see a goofy video. That's probably pretty early, but that came later. But that's the idea. The web browser basically took this kind of obscure niche technology and allowed Web 2.0 to happen, where we could all of a sudden look at it even as a non-technical user, right? And really, I guess Web 2.0 really starts to get into interactivity, right? So at first we had text, that was it. Then we had pretty text and web browsers to help us look at it. And then really came this crazy innovation called JavaScript that was added to the browser, which meant you could not only look at a recipe, but you could have an add to cart button that took the ingredients from the recipe and put them into your Target shopping cart, right? You could buy your groceries online, which is crazy. And I mean, now it sounds normal, but I still remember when it was really difficult to transact online and there was really low trust, right? So this is where PayPal starts to come in on some of these other companies that are building on top of this kind of web infrastructure that allows you to interact with a web page. So let's just pause really quick there and recap how we got to where we are, right? We started with the World Wide Web, which came out of nuclear fallout planning, and it was just a bunch of text files on a bunch of servers. Really hard to use for a non-technical user, not open to the world. And then from there, we get the advent of Web 2.0, which is we get pretty pages and interactivity. This changes the game, right? So all of a sudden we can do things online, not just look at stuff. And that brings us to where we are now, where we have too much stuff we're doing on the web browser, and it's actually slow despite our incredible technology. And I think one of the most interesting things I found here is that this is not a uniformly distributed problem. So one of the core difficulties, I think, and one of the reasons we've gotten to where we are, is there's this mismatch between who is creating the tech and who is using it. So like I work on a Mac, like a top of the line Mac, and I have really fast Wi-Fi. So most of the internet for me is fast. Now, one of the tricks here though is that internet access is not consistent and device performance is not consistent either. So really, even if you have a great computer, if you're on terrible Wi-Fi, the web's not going to perform well. And if you've got great Wi-Fi but a terrible device, the web is not going to perform well either. So problem we have here is the people making the internet today have the best of the best, and the people consuming the internet have a wide variety of things. So the people make it for the best of the best because that's what they have. That's all they see. So that's one of the reasons we got to this place where the web is slower than it needs to be, is we have this real kind of inconsistency with how things are running on the creator and the consumer devices. Another problem here is it's really hard to measure web performance, right? So even if, let's say you're a developer and you want to make your website super fast, well, what is fast? Is it how long it takes the page to load? Is it how quickly the page responds to a click? Do you measure it across all browsers, across all devices? And how do you measure it? Are you going to buy 100 different mobile phones and test out how well it does? Are you going to automate some testing suite and run it every time you commit any bit of code, right? There's so much overhead to measuring performance, and it's really unclear how to, right? Now, there's some stuff here. One bright spot here is Core Web Vitals. This is something that Google puts out and is actually incorporated into their Google search algorithm. But there's still not enough there in terms of the tooling to measure this on your own. So the two of the, I think, problems with how we got there are the people creating it are not very similar to the people consuming the web. And then two, it's really hard to measure web performance in general. Now, the third reason and the last reason I'm going to talk about is really centered around this question of why are web browsers free, right? And so this was a question that kept coming up for me is, all right, we pay for so many things, and this portal into the tech world is free, which feels strange, right? And this is really at the heart of the problem of the web, right? Is web browsers are not given away for no reason. Really, the modern web browser is a way to facilitate search or to lock you into an ecosystem, right? So the goal is either to make money off of advertising in the case of Google, or to keep you in the ecosystem in the case of Apple and Safari, right? And so that is part of the reason why speed is not critical. In fact, at Google at one point, they figured out autocomplete. And this was a long time ago. And when they rolled it out, it was faster for users, but it lost them search money. Because instead of typing out Facebook and searching for Facebook and clicking on the actual link, it would take you straight to Facebook. And it lost search revenue, so they rolled the change back. So that's just one small example of what's going on here. And you can look through my links to get more specifics. Right, so the 3 reasons we got to this place, in my take, as far as I can tell, is performance is hard to measure, the people creating are not the ones consuming, and then finally, browsers have some messed up incentives, and I highly recommend Incentives of Browser Companies. It's one of the 3 articles I highlight out of the, I think, probably 50 I read. It's incredible and a very good look. It's not technical either, so feel free to dive in there. And now I'm going to talk about how we get better and some bright spots. And it is this point, if you're not super technical, you're not super into tech, I would suggest you depart and look through some other links, because I'm going to get pretty technical here. So first of all, the web is built on JavaScript. JavaScript is not the fastest language ever, okay? There is a lot of work that's been done to make it faster, and that was actually a big part of how Google Chrome came into being. So there's kind of this browser history where Chrome is based on Chromium, which is built and maintained by Google. Chromium is based on WebKit, which Apple built. WebKit is based on KHTML, and I don't know where that came from or what it is, right? So those are kind of the core of web browsers, and Google's big insight in building Chromium off of WebKit was to really upgrade the JavaScript engine, right? So they did a ton of work on the engine, which is called V8, good name, and basically turned it into what it is today, and in a lot of ways allowed Chrome to become so dominant, right, in terms of performance and usability. So a lot has been done to improve JavaScript, and it's wonderful. I suggest JavaScript is the English of programming languages. It talks about the drawbacks and the positives here in JavaScript being the dominant language. But like I said, JavaScript is not the fastest, right? There's much quicker ways of doing things. Ultimately, I don't want to say ultimate. One way of making this faster, or a bright spot, is WebAssembly, right? So this is kind of referencing assembly code, which is one step above machine code, which is what, machines read. But most languages are going to compile down at some point to machine code, and the distance between the language you're writing in and machine code tells you the theoretical limits of its speed, right? So JavaScript is a couple levels up. WebAssembly is a couple levels down. So in theory, it can be faster, but 1, it's really hard to write. 2, the web is written for JavaScript, not WebAssembly. So JavaScript has a lot of unfair limit, like optimizations built in. And then, so to kind of solve the ease of writing, someone has created assembly script, which is like TypeScript, but for WebAssembly. I think it's a really great idea. There's this great article, Is WebAssembly Magic Performance Pixie Dust, that walks through the trade-offs. The short answer is no, and this is not ready. And another idea I had was using Rust and compiling down to WebAssembly. Based on an article, I don't think that's promising either. My central thesis here, though, was fundamentally wrong. My idea was JavaScript is bad because it's single-threaded. And while that's true, the web browser doesn't really work that way. The web browser is using lots of threads, right? Of course, the main thread where the DOM is controlled from is single-threaded, and that is a problem, and in a lot of cases a bottleneck. But the modern web browser is running lots of processes at once. It wasn't really the greatest way of looking at it. So that's one thing. The other one other really extreme approach, I thought, is just remove interactivity and kind of rewrite the browser. This would only work for certain use cases, but there's a really great article called My Experience with W3M, a console-based web browser. So in theory, you can rip out all the JavaScript and just load, HTML and CSS, and that does make it faster, but you also lose interactivity. So not a realistic approach, but an interesting one. One I really find fascinating is moving computing off of the machine and into the cloud, right? So the idea here being by moving the compute into the cloud, you kind of normalize for bad devices. So let's say you're using, like a Chromebook. Those are pretty limited in terms of CPU and RAM. But if you're using Mighty, which is this web browser, you're actually running, all you're doing is like sending interactions to the cloud, which then runs your code and sends it back to you on the web browser. It's an interesting idea. I mean, I think it's pretty promising. I've never tried Mighty. Like I said, I don't really need it because I have a pretty good work laptop. Now that said, I have a pretty rough personal laptop, so I might try that out and report back. Now, then the next most promising and more realistic way of fixing this is to send and use less JavaScript. So it's a great article called The Cost of JavaScript in 2018. Of course, a little outdated, but the idea here is really you're starting to use a variety of approaches to cut back on the amount of JavaScript you're running. One, it's costly to send JavaScript across the wire in terms of download time, right? So if you have a bad internet connection, the more JavaScript you send, the slower the page is. And it's kind of a flywheel / double, like a win-win here, in that the less JavaScript you send, the less needs to be compiled and run. So then in theory, you're running faster code. So I think that's pretty promising. In there, they talk about basically optimizations you can make with Webpack and Babel to basically eliminate unused code or to write code more efficiently. Another great one in there is really choosing your packages wisely. And this is something I'm guilty of, is just like Googling the first NPM package that pops up for what I need to do and using it. And it's a terrible approach. So I am going to try to stop using that. And there's a couple tools in that article that are really helpful for making that happen. Now, you could go the opposite direction and increase the size and the scope of the browser, right? So this is similar to rewriting it in something other than JavaScript, but there's more of a conceptual shift here of maybe the operating system is the browser and everything happens in the browser. And this is honestly Google's ideal version of the world. Since they can't seem to nail devices, they would like everything to be in the web browser, right? So this is why they launched Google Docs. They actually launched Docs before Chrome. And it's because, they didn't own the devices. So if they make everything a web application, all of a sudden they can compete on even ground with Microsoft and Apple. Whereas obviously if they're making operating systems, they don't have anything to put it on. So I think that's an interesting one. I am still wrapping my head around it. I don't know if I agree with it. But there's another, I think, even better article about this. I'm going to try to track it down, called The Web Browser as a Tool of Thought. I think that's a more promising way of thinking about it. But it's not super related to performance. But it kind of is. It might improve performance. I don't know. Next up is improve the JavaScript engine. This is kind of a stolen one from how Google made Chrome. And I don't honestly know how much room there is to improve V8. So not super psyched about that one. I mean, maybe in theory, there's a way to do things much better. I almost like the idea here of improving the WebAssembly engine, right? Like building an engine for WebAssembly that makes some of the same optimizations that V8 does, but that's more promising, actually. I like that. All right, next up is, and there's only a couple more here, leveraging web workers to bring things off of the main thread. So one of the biggest problems you have, especially when it comes to cumulative layout shift or time to interactivity, is you've got JavaScript code running on the main thread and it blocks the changes that need to be made to the DOM. So one of the theories for how to improve web performance is actually to keep everything the same speed, but just to break it up into smaller parts. And there's some problems with this approach that the state of web workers in 2021 laid out pretty convincingly. And so, right, that's one approach, is to say, okay, instead of making things faster, we're just going to reorder them. That doesn't tend to work because of the variability in devices, right? So if you make something much faster for one device, it might not be that big of a change on another device. And so it's really tricky to nail that down. The author lays out what I think is a better approach, which is kind of splitting out designations for like UI interactive and then kind of backend tasks. So like simulating front end and back end in the browser, with the idea being that everything that happens on the front end is happening on the main thread. Everything that happens on the back end is happening in a web worker. Kind of tricky to pull off. JavaScript is not really well built for this. But the article has a lot of interesting thoughts on it. And it really, tricky thing is, with reordering tasks, you can kind of pull that off without rewriting your code base. But with this kind of, they call it the actor model of UI and backend, you really have to rewrite it. So it's very tricky. The other article I read kind of related to this is Exploring the Magic Behind Google Chrome, which talks about how Chrome is built and why this web worker kind of paradigm is interesting. It's effectively trying to make JavaScript multi-threaded. Obviously, there's lots of limitations to it, but this is honestly one of the more promising approaches I've seen. All right, next up is, and the last one, is partial rendering. So this is kind of at the core of Hotwire, which is, and also Next.js, which are two projects. Hotwire is pushed by folks at Basecamp, or 30-second signals now. And then Next.js, I don't know who supports it. It might be Vercel, but the idea is basically you just break up your UI into your smaller parts, and you only send those across the wire as they change. Obviously, this doesn't really work for like all applications. This is really great for, I guess, like true applications that are doing something like, I don't know, like Instacart or something, but it's not great for a blog where you kind of want to have everything preloaded. So limited again, but interesting. So there's the technical part. I'll do a quick recap here. So when it comes to fixing the web, it's really difficult. And honestly, this was kind of the depressing deep dive in some ways, as much as it was fascinating. There's really tough trade-offs that happen when it comes to improving web performance, and we're really limited in our ability to make this happen. But yeah, that's kind of a bummer of a report. But the best we can do with JavaScript is to, if you're starting from scratch, fundamentally rethink how you use the main thread and kind of splitting it up into UI and background threads with web workers. That's supported on all modern browsers. Another great one that's more incremental is just limiting the amount of JavaScript you send to class and choosing your packages really carefully. So those are the two kind of takeaways I have. There's a lot more there, which you can dig into in the kind of notes that I have written up that are linked in the show notes. But yeah, at a high level, that is it. This was really interesting. I got really into the weeds here, and I am so thankful for the opportunity to do it. So thanks, folks.